In these questions, we're going to be using the ideal gas law. Let's head to the reference sheet. On our reference sheet, you'll see that there are two different ideal gas laws. There's the ideal gas law for particles of gas and the ideal gas law for moles of gas. And you'll see they look very similar. Both of them have PV on the left. P is pressure and V is volume. Then on the right, both of them end with a T. T is our temperature. But the first one, the particles of gas law, has a big N and then KB. The big N represents the number of particles, and KB represents the Boltzmann constant. For the moles of gas law, the little n represents moles of gas, and the R represents the molar gas constant. We can see over here Boltzmann's constant, KB, is 1.38 times 10 to the power of negative 23 joules per Kelvin. And the universal gas constant, or the molar gas constant, R, is 8.31 joules per mole Kelvin. So for particles, we've got PV equals N KB T, where KB is the Boltzmann constant, which is 1.38 times 10 to the power of negative 23 joules per Kelvin. Or we have the gas law for moles, which is PV equals lowercase n RT. And in this case, R is the universal gas constant, or the molar gas constant, which is 8.31 joules per mole Kelvin. One other thing that needs to be mentioned is that the temperature has to be measured in units of Kelvin. If the temperature isn't given in Kelvin, but it's given in degrees C instead, we can calculate our temperature using this equation. Okay, so let's go ahead and solve this first problem. Here we have a container of an ideal gas that has pressure, volume, and temperature as shown in the diagram. Our goal is to figure out how many gas particles are in the container. So we can see here we've got a pressure of 337 pascals, a volume of 3.53 meters cubed, and a temperature of 334 Kelvin. We need to figure out how many gas particles we have. So we're going to be using the particles equation in this question, which means we're going to be using KB, the Boltzmann constant, and we're going to be using our equation PV equals N KBT. So we're trying to figure out the number of gas particles. That's the uppercase N in our equation. So to get that on its own, I'm going to divide by KB and T on both sides of my equation so that I can cancel out the KB and the T on the right-hand side, leaving me with N is equal to P times V divided by KB times T. So all we need to do now is go ahead and put in our numbers. P is our pressure in pascals, which from our image is 337, multiplied by volume, which from the image is 3.53 meters cubed, divided by KB, our Boltzmann constant, which is 1.38 times 10 to the power of negative 23, multiplied by T, our temperature in Kelvin. Now the question gives it to us in Kelvin here. It's 334 Kelvin. So now what we need to do is go ahead and put that into our calculator. That's going to get us an answer of 2.58 times 10 to the power of 23 particles. So we can go ahead and fill that in our answer box. On this platform, times 10 to the power of is written with an E. So 2.58, then we use E to represent times 10 to the power of, and then we write 23 to show 10 to the power of 23. Awesome. Let's do one more question of this type. A container of 0.210 moles of an ideal gas has volume and temperature as detailed in the diagram. The diagram shows us our volume is 2.95 meters cubed, the temperature is 82 degrees C, and our pressure is unknown. The question asks us, what is the pressure of the gas in the container? So because we were given moles of gas in the question, we know we're going to be using the moles equation, which is PV is equal to nRT, with a lowercase n showing moles of gas. That uses R, which is the universal or molar gas constant, 8.31 joules per mole Kelvin. For our temperature, it's given in degrees C, so we're going to have to convert that into Kelvin. To get our temperature in Kelvin, we take the degree C temperature, which is 82, and we add 273. That gets us a temperature of 355 Kelvin. So that's the temperature we're going to use in our calculation. So our equation is PV equals nRT. We're trying to find P, the pressure. So I'm going to divide by V on both sides of my equation so that it will cancel out on the left. And I'm left with P is equal to nRT over V. So we can go ahead and put in our numbers. N is the number of moles, which is 0.210 from the question, multiplied by R, which is the universal gas constant, 8.31 joules per mole Kelvin, multiplied by T, the temperature in Kelvin, which we calculated is 355, divided by V, which is the volume given in our diagram as 2.95. That gives us a pressure of 210 pascals. So we can go ahead and fill that out in our answer box. So for these questions, your first step is to figure out if the question is about moles or particles. That will help you choose which of these two equations to use. Then that will help you decide which constant you're going to be using, the Boltzmann constant or the molar gas constant. Then you need to make sure your temperature is in Kelvin. If it's in degrees C, you're going to have convert it into Kelvin first before you can use it in your equation. Then you'll rearrange your equation for your unknown variable, solve, plug in your numbers, and get your answer.